Hello everyone, welcome to another video. Today we're going to be working on this Nintendo Switch which has been sent in by a customer, and this Nintendo Switch has got a few issues with it which are all directly related to each other. From what I can tell on this, there's 3 issues on this and they're all going to be caused by 2 parts on the board. So this is a 2101-0001 error code. And basically the 0001 error code is directly related to the charging port and the M92T36 power management IC. The M92 power management IC is basically responsible for all power coming into the device and then distributing it to other places such as the battery management and other things like that. So it's a relatively straightforward fix if you've got the tool, but if you haven't got the tools and you need this issue fixed, check out the link in the video description, consolefix.shop, and I can fix it for you. I charge a flat fee of £50 for this, which includes the charging port and the charging controller IC. Even if the charging port looks good, I'll replace it anyway as part of the service because it's just good practice to do so. Today's video is sponsored by PCBWay. Whether you've got a simple project that requires a quick mod board or you want to launch your own products to the world, PCBWay can help. With fantastic pricing on multi-layer PCBs, flex PCBs, 3D printing and even laser cutting solutions, you're sure to get everything you need all in one place. Custom PCBs start from just $5 for a 1 to 2 layer board with a fast 24-hour build time and free shipping on orders over $30. PCBWay are also proud to announce their new aluminium PCBs which start at just $120 per square metre. Check out what PCBWay have to offer by clicking on the link in the video description or the top pinned comment and get your project started today. Thanks again to PCBWay for sponsoring the video. Let's get back to the repair. So let me just show you what's going on with this and then I can get it apart. But as you can see here, we've got a 5 volts output on the charger and we've got 100 milliamps of current draw. So it's not negotiating 15 volts, which it should be, but we've got a constant 100 milliamps of current draw, and that's important because it might look like it's charging if you've got an ammeter. It might look like it's charging, but it's not. That constant 100 milliamps of current draw is basically because of a short on the board. Current should never be static. It should always be dynamic. It should always be fluctuating. So it should always be bouncing up and down, up and down, up and down. Being as that this is a solid 100 milliamps, that's telling me that it's got a short on the board. That short on the board is going to be M92T36 because of a damaged charger port. So I'm not going to be able to actually charge it, but I can attempt to turn it on. If I can't turn it on because the battery is dead, which in this case it looks like it is, I've got a custom made bench supply cable just here. This is connected up to my bench power supply and that outputs 4.2 volts. Replicates a full battery, allows me to do fault finding a lot quicker. I'll sell these on my online store. I hand make them, by the way. So if you want to buy one of these and you don't have the ability to make them, they are really simple to make. It's just a battery board from a original Nintendo Switch battery, and then that's onto some cables and onto some banana jacks to connect it to the bench power supply. You can connect it to a USB or whatever. It can support up to 5 volts, but I wouldn't recommend putting it into 5 volts because it's only designed for 4.2. But anyway, they are easy to make, so if you do want to make one yourself, just strip down an old battery, connect it to some wires, and away you go. I might make a video on that at some point. If you see paint on my coat, it's pretty cold tonight, and yeah, I don't have another coat clean. I've been painting in the new workshop, so it is what it is. While I'm taking this apart, if you are new to the channel, don't forget to subscribe, turn on the bell notifications. We are edging closer to 100,000 subscribers as of recording this video, and I would really appreciate it if you help me get there. I don't mean to take that freaking kickstand off, it just fell off, alright? Never mind. It goes back on, it's fine. But yeah, don't forget to subscribe, give the video a like, give it a thumbs up, all of that good stuff. And if you do want to support me as well, I do have a Patreon page. You can check that out, links in the description, patreon.com/Lakoda. Or if you need some parts and supplies to repair your own device, I do have an online store as well, consolefix.shop. Anyway, I'll skip past this bit. Now that I've shielded the store, shielded the Patreon, I'll skip past it and I'll get to working on, well, I'll get to disassembling it and then I'll work on the device. Okay, so I'm inside the console. As you can see, it looks fairly clean. Liquid damage indicator hasn't been set off, etc. What I'm going to do is just unplug that battery, and I'm going to plug in my bench cable. And there we go. And let's attempt to boot it up. So I'm expecting to see a 2101001 error code here. That's what's been reported on the booking. Slow boot up as well, so that's an indication of a fault. And yeah, okay. So yes, there's actually 4 issues. Then we've got slow boot up, we've got the 2101001 error code, we've got what's reported as a bad charge port, but I would have changed it anyway. Is it? No, that's just three issues. Yeah. Anyway, never mind. All right. So let's fix them all, and yeah. I don't know what I'm saying, but never mind. It is 1:40 AM right now, and dedication to the cause, I'm recording a video. So I'll just get this board out. Like I said, this is a relatively simple fix. It's always caused by this chip here. I will verify that with the multimeter, but if I wasn't making a video, I wouldn't even bother because it's always caused by that chip. I'll just verify that for the sake of, you know, the video's sake, integrity and all of that, and to show you actually how to fault find it. But it's always caused by that. I'm under no illusions that it's going to be caused by that. Relatively straightforward if you've got the tools to do so. I'm just going to set my hot air up to 200 degrees Celsius just so I can remove this foam. I don't like to damage these if I can help it, so I'll just heat them up normally. Just don't use too much heat because the plastic is very, very thin on these things. I always keep the plastic, the airflow moving, just to make sure I don't damage it. But I have damaged them in the past, so just be warned. There we go, that come off nice and clean, and I'll be able to stick that back down. And sorry, it was 4 issues. 5 volts on the charger, and one thing I did notice as well, it's only charging on one side. So if I plug it in that way, we're getting that 100 milliamps of current draw. But if I flip the charger around like that, we get nothing. Right? Nothing at all on the charger. So yeah, that's another issue. That's what I thought it was for. Alright, let's clean off this old thermal paste first because that's got to be replaced. Let's pop it under the microscope. Alright, so taking a look first at the charge port, we can visibly see that the port is damaged. And the pin that's damaged, the very specific pin which is damaged, is pin number 4. Now, pin number 4 on the USB-C port is VCC. It's basically what provides power to the entire board, or VDD, whatever you want to call it. It provides power to the board, and the fact that that pin there has shorted out across other pins is what's caused this issue. So just to the right hand side of the VCC pin, we've got some data lines. And those data lines go to not only M92T36, which is this chip just here, but it also goes to Pi3 USB, which is this chip just here on the other side of the board. So this chip here is for main power. So that distributes power to pretty much everywhere, including the charging IC, which is this chip here, the video IC, which is this chip here, but that's also responsible for docking as well. It also provides power to the audio IC, to the main max IC, which is another power management. You kind of get the drift. It goes everywhere, and basically because that pin there has touched some of these data lines, that's caused this chip to short out, and that's what's causing the error code. So you can see how the damaged charge port directly correlates to the 2101 error code, which is caused by the power management chip. It's a power management issue. That's what the error code means. So we need to change the chip to fix the 2101 error code, but we also need to change the charge port, because otherwise as soon as we power this on, it's going to happen again. And I always change this whether or not those pins look good, just for good measure, like I said. But yeah, let's get that done. So we'll start off with the port. So the first thing I do here is to hover the board over the edge of the table. And the reason for that is because I don't want to put any direct heat on this side of the board, because just under this shield off to the side, just there, sits the RAM. And if we put too much heat on that, it's going to do what's called floating. So the RAM is a BGA, which stands for ball grid array. That means that there are tiny little solder balls underneath the chip, and that's what makes the contact with the board. If we put too much heat on this side of the board, and believe me, it doesn't take much because these boards are ultra thin, but if we put too much heat on this side of the board, we can float the RAM, and that can cause connection issues, which would also cause no power. So right now this console turns on, and I don't want to cause any further damage. So I always heat up from the bottom of the board to prevent any damage to the RAM. It wouldn't be the end of the world if that happened. It would just mean that I've got to take the RAM chip off and re-ball it. And I really don't fancy doing that. So add a little bit of flux, and I'm going to go for 380 degrees Celsius on the hot air, 40% airflow, and I'm going to heat this up from the bottom of the board and get ready to remove the charge port. Okay, so that solder's flowed. The back ground legs have flowed. Let's give it a tap. That's nice and loose. And then we can remove it. And the reason I gave it a tap before I removed it is because I want to make sure that every single point is basically molten. Because we've got pins under here, and these pins, if they're not molten, and we try and lift it up because these ground legs are molten, we're just going to rip all of those traces clean up, and we don't want that. We want to avoid that. So you'll have to excuse the fact that the light's bouncing off the metal. Unfortunately, there's not a lot you can do about that. It's fine for me under the optics, but unfortunately the camera doesn't like it. I'm going to add a little bit more flux. You can never have too much flux, and if you clean it up, then it's not an issue. So I'll add some more flux, and then I'll take my soldering iron. By the way, people always ask me what temperature I use my soldering iron at. It really depends on the job. If I'm doing something with a big ground plane, I use 450 degrees Celsius on my Hakko FX951. But 99% of the time I've got my soldering iron set to 400 degrees Celsius. And that's what I've got it set at right now. 400 is what I've found to be the sweet spot. It tends to do most jobs. So I'm just adding some leaded solder to the solder pads and the ground legs, or the ground holes. And that will lower the melting temperature. Leaded solder is a much better contact, or rather much better solder. So I always use leaded, but it lowers the melting temperature, makes it easy to put the new port on. But what I'm going to do is, again, heat up from the bottom. Never heat up from this side of the board when you're working with the charge port. You don't need to, the board is thin enough. Do it from the bottom. I'm going to flow all of these until the solder drops through the holes, which it will do in a minute. It might not actually, there's quite a lot of solder inside those ground legs. I'm going to flow that. Yeah, it's not going to drop. I'm going to keep the airflow moving and drop the port on. Keep the airflow moving. Press on the board. Again, keep the airflow moving. Always keep the airflow moving. That'll prevent you from damaging the charge port. There shouldn't be any melting on the bottom of this port because I kept that flow moving. Wait for it to solidify, and done. That's called the drop method. So the drop method is basically where you heat it up, you flow all of the solder, and then you just drop the component straight on. Bring this onto the bench now, and I'm going to inspect these pins. First I'm going to clean up. So I'll just clean up with some isopropyl. Isopropyl alcohol, I should say. So it's 99.9% IPA. I just want to get rid of any flux, just so as it makes it easier to inspect it. I mean, I will clean up at the end of the job anyway, but for now, I just want to be able to inspect it. I'm just going to clean up as best I can. There we go. And I'll just dry that up with a cotton swab. You don't need to dry it up, it's isopropyl alcohol. It's non-conductive, but it just makes it easy to be able to see. Notice I've got some really nice joints on those ground legs, and that should reflect on the other side of the board as well. So I'm going to do what's called the nudge test. Just give all of these pins a nudge. Not too hard, but just enough to know whether they're all connected. There should be. I think one of those might have moved slightly. Did it? No, it's fine. It was just me. Never mind. Okay, that's all nice and solid. But if we look on the other side, you'll see we've got no melting. In fact, we haven't got good joints on this side. Let's fix that. Can't leave that like that. It wouldn't hurt it, but it just doesn't look good, does it? So we add some flux. Random hairs all over the place. My bench really needs a good clean. So I've mainly got to remove solder from this because there's too much on the bottom. The board wouldn't sit flush like that. At least I don't think it would. So you can remove solder without using wick, just heat it up basically. Notice how quick the heat transfers to the rest of the ground plane. So I touch this part, and within seconds the flux over this side starts to melt. There we go. That looks a million times better. I'm happy with that. Right, I will clean up in a little while. I'll do the cleaning all at the same time. Let's just do some tests. So this Pi 3 USB chip, like I said, this is a video IC. I just want to check and make sure we've got no shorts here. And we do not. And I'm going to make sure that we haven't got any blown EMI filters, because that would prevent any docking. So we're looking for a beep from top to bottom on each of these. There's 2 filters on each of them. We're looking for a beep from top to bottom. We don't want a beep from left to right. So I would go like that, test that one, and then move back across and make sure that that one's not shorted. So if we have an issue where we've got a short from left to right, that means we've got crosstalk on it, because each of these are data lines, positive and negative. And we don't want that. And yep, that's good. Okay, so Pi 3 USB appears to be fine. I'm expecting to see a short on these top 3 caps here on M92. So I'll connect ground. It's going to be one of these ones, I think. Maybe not. It's not showing up as short. Interesting. So that's a little bit, well, deceiving, to be honest. So it's not showing up as short. It does sometimes. But that doesn't mean the chip's not bad. What I will do, I don't want to do any work that I don't have to. That 2101 error code could very well have just been caused by the bad port. So let's double check. I mean, either way, it doesn't make a difference to me because it doesn't affect the cost that I'm going to be charging the customer. You know, charge port is exactly the same price as the chip. And like I said, I only change the charge port for good measure in this case most of the time. But let's just double check this just to see what the deal is. So I'll connect up the LCD. I can prompt it to boot by just shorting out the power pins on the connector. So that's absolutely fine. So as long as I've got the LCD connected, I can see what's going on. That's all I really need. Okay, that's booting. There we go. Just wasn't in fully the LCD connector. We've still got slow boot, which means we're probably going to get this error code. Yeah. Alright, so even though M92 is showing up as good, it's not. It is very deceiving, so don't pay any attention to that. Honestly, just change M92 anyway. Save yourself some time. I mean, if you want to save yourself some money, you can always try it. You know, you might get lucky, but it's very rare that I've found M92 to not be bad when we've got this error code. I think probably once or twice in my entire repairing career. So M92 is going to come off. We're going to change it. It's fine. So one thing you'll notice, I don't use any flux when removing this chip. And the reason for that is because I don't need to. There we go. That I like to call the yeet method. So literally grab the chip, lift it up slightly off the desk, and then as soon as it's ready to come off, the board will drop, because the board's quite heavy compared to the chip. So gravity will just take over and the board will drop, and the chip will stay in your tweezers, if you do it right. So notice I've still got quite a bit of solder on there. That's why I didn't want to use flux, because it keeps all of the solder intact. So what I'll do here is I'll position the chip. So I'll get the chip in position before I use any hot air. And because I didn't use flux, the solder hasn't flowed back onto the pads. So that makes it easier to position it. Press down on the chip gently for a couple of seconds, just while I heat up and partially solder this chip on. Damn it. God damn it. That wasn't meant to happen, was it? Okay, I'll hold it in the tweezers. Okay, so that's partially soldered. So now what I'll do is I should be able to pretty much tap this chip and it won't go anywhere. Yeah, so I can tap the chip and it won't go anywhere. So it's partially soldered on. So now I'll add a little bit of flux. And what you're going to see is surface tension take over. And the chip will literally just align itself. Because it's already almost in line, the chip should just align itself and I shouldn't have to touch it. And you might ask why I'm not replacing the solder. I don't need to. There's nothing wrong with the solder that's on there. What's the point in risking knocking components to replace solder that there's nothing wrong with? Okay, surface tension didn't take over, so I've had to sort of intervene a little bit just to give it a nudge into position. I press down on the chip now. Remove the heat, wait for it to solidify, and done. Nice. Let's add a tad more flux. And then I'm just going to run over with the iron. I use a bevel tip for this, and the reason is it allows you to get into angles better. So I'm going to make sure my iron's clean. And just run over each side dragging the iron across. And this is another reason. If you look at this, I'm using a pretty big tip here. Just about passes that capacitor. Just about. But because of the angle, it makes it a lot easier. I've just realised I've knocked a capacitor. How's that happened? I never knock capacitors. See, and this is what I was talking about risking knocking components. Alright, let me just fix that. Not having to make a difference anyway to still work without that cap there, but let's just fix it. There we go. Wonky cap. Sort of my trademark. Alright, we're good. Let me just make sure that I didn't put a bad chip on, because this is a donor chip that I'm using. Good. Awesome. No issues there. Or at least it seems to work. So let's just clean up. So I'll use a bit of IPA again. I'm going to clean up the entire board now. So I have got some new chips here, but I need to test them because I haven't long had a delivery of them. I need to test them before I can use them on customer devices. I don't trust brand new M92 T36s enough to be able to just install one. I need to install one on a board of my own, which I just haven't had time to do yet. Alright, so one final step as well, always make sure that you clean inside the charge port, because believe me, that flux will find its way in, and then you will have charging or docking issues if you've got dried flux on the pins. And it might not even show it immediately either. It could show it when it goes back to the customer after he's had time to dry and harden. So I always clean the port out thoroughly before reassembly. Good stuff. Okay, let me just check and make sure that it's charging on both sides of this port. Okay, we've got 15 volts. And notice how the current's just dropped back. So we're not drawing any current now because it's not detecting the battery. And we've got 15 volts, should drop off. There we go. Yep, that appears to be fine. Let's reassemble it and give it a full test. Hopefully, we've got a working switch. Alright, so it's back together enough just for testing. I've got everything plugged in. I haven't added thermal paste or anything yet, but I'll do that afterwards. It's fine. But what I'll do is just connect my bench power supply up to it, because I know that it's going to give me a, well, replicated full battery. And just basically use that for testing. And as long as that works, then I can give it a full charge and make sure it works. We do seem to have a faster boot up. And there we go. Yep, absolutely fine. Touchscreen's working. Awesome. So this console's now fixed. The issue, like I said, was related to M92 T36, but that was caused by the bad charge port. So replacing the charge port and replacing the M92 T36 chip, that's got this console working again. And yeah, hopefully the customer's going to be happy. I do still need to apply fresh thermal paste as well as give it a full test, and also, you know, give it a clean and stuff, and then it can go back to the customer. So that's going to be it for now. I hope you enjoyed the video. Hope you learned something. If you do have any comments or questions, leave them down in the comment section down below. I'll always do my best to answer. If you do want to organise a repair, check out the website consolefix.shop. You can get in touch, you can book it in, etc, etc. That is charging the customer's battery, and it's all working. So that's going to be it for now. Thank you for watching. I really appreciate it. And until next time, I'll see you later. Bye for now.